Okay, number 3 is going to be a little bit of a longer proof. We're trying to show that the outlying figure MOPR is a parallelogram. A couple different ways to do it, depending on the information that they give us. We determine which method we use. So now, what it tells us that RSOT is a parallelogram, it tells us a couple things. It tells us, one, that its opposite sides are parallel, and they're also congruent. Okay, so that's helpful. How that's helpful is that if these are parallel, that means that we'll have alternate interior angles that are congruent. In this case, we have angle 1 and angle 2. It also means that those two segments are congruent. Now, when we keep in mind that it was given that MS was congruent to TP, when you look at this, you have the triangles at the top and the bottom, right here and right here, are congruent. We use one more step here, and that's using that 1 and 2 are congruent, so their supplements, which are right next door, which would be 3 and 4 are congruent. So now you have those yellow triangles are congruent by side angle side. Okay. So knowing that, what we're going to say here is that if those two triangles are congruent, it means that the corresponding parts are congruent. In this case, 5 and 6 are congruent by CPCTC. And if that's the case, then we know that the top has to be parallel to the bottom because the alternate interior angles are congruent. Right? So we established the top and the bottom are parallel, and then if we just use the fact that those triangles were congruent, the top and bottom are also congruent. So what we've just done using CPC was to say the top and the bottom are congruent. The step before it said they're parallel. So if you have a quadrilateral and the opposite sides are parallel and congruent, we're going to call it a parallelogram.